Hello and welcome back to day 4 of this Mule advanced training. In this video, you'll understand about synchronous processing strategy, idempotent processing, and quick acknowledgement pattern. As an architect, you should know all this so that you can apply these patterns whenever required based on your scenario. So I'll tell you all this with very good examples so that you'll get a good understanding. So let us get started. Let's talk about one more processing strategy called as synchronous processing using request reply pattern. What do I mean by it? Let us see. Assume that there is a third party SOAP web service or REST web service. Now, I want to write a flow where I'll have a HTTP listener and something. Here, I want to make a request and get response. I want to make a request and I want a reply also from either SOAP web service or REST web service. So if you want response, then you have to configure your flow to wait for response. So basically assume that you don't know what is a service. Suppose this is within your organization, you have multiple services which needs to orchestrate. How to design communications. So let's assume that you have API 1. You'll be having multiple APIs within your organization, right? API 2, API 3. You should be able to now take a decision how these APIs will communicate with each other. Normally, we design using REST. API 3, if it wants to call API 1, it will make a REST API call. So API 3 wants to make a call to API 1 and wait for response. So we should actually design API 3 to wait for response. But what if you are sending too many calls to API 1? Too many calls to API 1. Suppose the request coming to API 1 is 100 requests per second. Assume that you know that this API will be getting 100 requests per second. Then how to actually expose this API? If I expose it as REST, then 100 requests per second has to be handled by this API. Assume that I'm deploying all my APIs on premise. Assume that I'm not using Cloud Hub. I'm deploying all my APIs on premise. So what if one instance of my API is running and if it is getting 100 requests per second, I know that the processing will become very slow. So how to improve the processing? Is there any way to improve the processing? Yes, please give me a suggestion. You want to develop an API where you're expecting 100 requests per second or 200 requests per second or more. Your API should be able to process this many number of requests. And assume that each request takes a good amount of time. Assume that each request takes 0.1 seconds to do processing. For each request, the API will take 0.1 seconds for processing. For example, what solution you will propose? How do you design this API one? Do you design this to receive REST API calls? If you have designed it to receive REST API calls, what you might have to do is you might have to run multiple instances of API 1, behind a load balancer. Then the API, whoever is calling, they will hit the load balancer and load will be distributed across the multiple instances. Right. So we could actually increase the number of instances on demand dynamically. Right. We can have a load balancer like this. This is one solution. Or instead of exposing this API over REST, I would suggest this API should be receiving messages through a JMS broker. This API, if it can receive messages from a queue and then process it, the other APIs which want to send a message to this API will put a message on the queue, right? And now, if the load on the system is more, the number of incoming messages are more, what I can do, I can actually start multiple instances of my API. All of them will be consuming from the same queue. Load will be automatically distributed. But this API wants to send a message and also get the reply request, and also it wants a reply. So is it possible to get reply or response? Request, and I want to get response after sending a message. Is there a way to wait for response in this API? Tell me. In case of HTTP, that's okay. We'll make a request and we'll get a response. But in case of messaging, is there a way to actually get the response also? Wait for response also? Please tell me. Anyone? Yes, there is. In JMS module, let me just create one more XML.
Sorry.
Yes.
Can you repeat the last one? Yeah, can you repeat the last one? The solution you suggest the only with the load balancer, and the another solution you are recommending the queue. So,
yes, one solution.
Exactly what was the problem? Yeah, the problem, and just summarize or like.
Sure.
Works. Okay, thank you.
Assume that you have to design an API and you are expecting that this API should process dynamic load. Maybe sometimes you might be getting 100 requests per second. or 200 requests per second or 300 requests per second. You have to take a decision on how to design your API. Suppose if you have designed your API so that you are exposing a REST API, then if there is only one instance of the REST API, one single instance, it will become slow because the number of requests which are coming are more. So one solution could be you can actually have multiple instances of your API behind a load balancer.
Sorry. Okay, sorry. What was the multiple instance or API instance when you say multiple instance?
You should have the same REST API. This application, whatever Mule application you are designing, you will be exposing a REST API, right? So run multiple instances. That means, suppose if you are working with Cloud Hub, you have an option of specifying the workers, right? You want the same application to run on multiple virtual machines. Suppose if I say 3 workers, that means my application will be deployed on 3 virtual machines. Similarly, on-premise also, I want my application to run on 3 servers, on-premise, 3 instances. And I'll put a load balancer in front. So the APIs will go to load balancer. That whenever somebody is calling my API, they will actually hit the load balancer. Load balancer will take care of distributing the load across the instances. This could be one solution. And the API, other API can make a call, wait for response until it gets a response. Yeah, this is one solution. But you need a load balancer in front. If you are working with Cloud Hub, that is fine. You will be automatically provisioned with a load balancer. But on premise, you need to have your own load balancer configured. Okay, so based on where you are deploying, also your decision should change. Yeah, now tell me, what is your question? Is it clear?
It's exactly correct. So the answer, thank you.
Okay, now the other solution is, assume that we have a message broker and we have configured a queue. Now my API can be configured to listen for messages in this queue and do the processing. So if there are more number of requests coming, more number of messages coming in this case, 200 or 300 requests per second, then what we could do is simply we can increase the number of instances. All the instances will be getting the messages from same queue. So in this case, 200 messages can be parallelly processed by multiple instances, right? The load distribution happens automatically in case of messaging. So the other application, whenever it wants to consume my API, the other application will put a message on this queue. The message will be processed by any one of them. But now my question was, this API wants response also after processing the message. How is it possible to get a response? Normally messaging is asynchronous, right? You just put a message over here and it can be processed anytime. But you need to make sure you need to get response. So how is it possible? Yes, of course, it is possible. Let me just add a JMS module, for example. Instead of just publish will just publish a message. Publish consume will actually publish the message and wait for response in a temporary queue. So in this application, I would write a flow which will use publish, consume, and configure this to publish a message to this queue. But from where can it consume the response? Yes, can anyone tell me? And actually, it is publish, consume, it has to wait for response. So where will this component wait for response? Once we put a message over the queue, it will be processed by any of the API instances. How the API instances will send a response and how this will actually get the response. Very simple. Whenever this publish consume is putting a message over a queue, it will create a temporary queue. It will create a temporary queue on the broker. And whenever it is publishing a message, in the message, there will be a header called as reply to header. It will put this temporary queue name as reply to. So publish consume will put a message with reply queue as temporary queue, whatever. If any one of the instance picks up the message, it will send the response after processing whatever response is there. This will keep the message on this whatever queue mentioned in the reply to. So this publish consume, after it publishes, it will wait for responses in this queue and get the response. So like that, you can actually design your APIs. You have to decide whether you have to expose your APIs using REST or messaging. So even when the API is exposed using messaging, we can get response, right? So that is one way to design. So that's what I was talking. We can actually use request reply pattern, either using SOAP, REST or JMS. Here, this is synchronous processing only. That means in this application, if we are getting a request, publish, consume will wait until the response comes. So if you are using components which support request response while consuming, still this is synchronous processing only. Using publish consume, you will be able to get the response. Or suppose if this is exposed over REST only directly, then you know how to consume a REST web service synchronously. So this is another way, right? Again, this is also synchronous processing. So you should be able to decide as an architect, first of all, when designing this API, whether to go with messaging or not. When to go with messaging? When your API is expecting huge traffic and you want to process those messaging, and also you want configure auto scaling. Automatically, you want the number of instances to be scaled still they can distribute the load. So in such cases, you can go with messaging. Otherwise, you can go with HTTP only. Okay. So we'll discuss about the next pattern, synchronous processing only. What is this idempotent pattern? So let us discuss about what is this idempotent pattern. So I'll tell you a scenario. Assume that I have a simple flow with HTTP listener. Whenever I get a request, I want to add data into database. Okay. So assume that I have a table called as product. Okay. And this flow is getting data for adding a product. We are doing some transformation, and then we are inserting a row into product table here. Insert. What will happen if there is some temporary network problem here between the database? The insert will fail. No problem. If insert fails, in this case, the client will get a response saying that there is some problem, and the client may retry. Okay. The client may retry. But sometimes, whenever we are supporting retry, sometimes it is also possible that the client may send some duplicate data. For example, let us assume a scenario where the insert component has sent the data to database. But immediately after the data is sent, insert also was done successfully. But by the time the response comes, there was some network problem. It is possible. Insert was actually successful, but there was some network issue. While the response is coming, this component didn't get the response. So this component will throw an exception or an error. We can handle the error in the flow. Assume that we are giving error response. So the client knows, okay, there was some problem, and the client will do a retry. Now in this case, what will happen? Again, duplicate data is coming. And maybe if you don't take proper care, maybe duplicate data also will be inserted into database. So we want to make sure that how many hour times the operation is tried, there should not be any side effect. The response should be always same. So that's where idempotency comes into picture. Idempotence. If you want to make your flow as idempotent, that means how many times this flow is called with same data, there should not be any side effect. Then we can say that the flow processing is idempotent. How can you make your flow processing idempotent? Yes, Mule has a component for this, for idempotent processing. Here it is. I have a component called as idempotent message validator. Assume that in this flow, I am expecting some product details. What is the second component doing? By extracting the data, it is creating a object, maybe JSON, whatever. Okay. Then if the product with same data comes, we should be able to identify that this is duplicate data, and we should throw an error, right? So see here, I have used component idempotent message validator, where I can actually write an ID expression. Very interesting. See here, before idempotent, I have kept a transformer to store this transformed output into a variable called as product. In this idempotent message validator, what am I doing? I am writing an expression to pluck all the values. Pluck all the values as an array. So pluck operation will give all the values as an array. Then I'm joining all the values by using dash. So I'll be getting a big string with all the values separated by dash. So this is an ID expression. Whenever a request comes to this idempotent processor, this expression will be evaluated, and this value will be stored by this idempotent validator in something called as object store. So we will discuss about object store just now in some time, but assume right now you might be knowing as well, object store can be used to store key value pairs. So here I have configured object store to refer to this one, where I made my object store persistent. Maximum number of entries is 100 key value pairs can be stored here, and TTL I gave as 1 hour. That means until 1 hour, the object store will store the key value pair. So if you see this flow, the idempotent message validator, it will evaluate this expression, which will get all the values of the payload separated by dash, and it will be storing inside object store. So if a duplicate request is coming, what will happen? Idempotent message validator will check, is there an ID with same name in object store? If yes, it will throw an exception. And I'm handling this exception inside on error continue. And I am just printing a message, duplicate message, product was already added. So if it is a first request, there will be no such ID in the object store. The control will go to insert and it will do the insert. Okay. So let us check. Okay. Now I'll have to give a request / add product idempotent. Here I have add product idempotent, and I'll give the ID. I think in database, I have some products up to product ID 6. Just I'll give 50 as ID, and I'll try to add one item. See what? I got a response inserted successfully. This one. Let us check in database. See, product with ID 50 is inserted. Okay. Now, if I try to send the same ID and same data, now see what? I'm getting a message, duplicate message. Product was already added. So that's how we can use idempotent message validator to make sure that the flow processing is idempotent. So wherever in your application, wherever you want idempotent processing, if there is a chance of duplicate messages to come, and if you want to make sure that your processing is idempotent, you can use this idempotent message validator provided by Mulesoft. Any doubts till now? Let me know. Okay. Yeah, please think. If you have any queries, let me know. Sorry.
Sorry, I have a question. So,
please.
Without using idempotent object store, is not able or is not a capacity to do this one, like if we are using object store?
Yeah, it will use object store. Otherwise, there should be some place where this idempotent message validator should store this IDs. Somehow there should be some storage where it should store. That is what is object store. If you don't configure by default at Mule runtime, there will be a default object store. So it will use it. If you want to have a customized behavior, you have to configure the object store. And in this object store, I said max entries is 100 and TTL is 1 hour. That means after 1 hour, the entries in this object store will be deleted. That means this idempotent message validator can guarantee idempotent processing within 1 hour. So within that 1 hour, if same duplicate data comes, it will handle it. After 1 hour, if duplicate data is coming, again, it will not be able to identify that this is duplicate. So in such case, maybe you can give a longer TTL, or you can make it 0. That means it is infinite. So the data will be present in object store. It will never be deleted. Okay. So, or better, don't end up keeping 0. Better keep up more, like maybe 24 hours if required. Okay. That is the idea. I hope now it is clear.
Yes, thanks.
Okay. So now let us go with the next strategy. Again, synchronous processing strategy with a quick acknowledgement pattern. What is this? Assume that whenever a request comes to your flow, you know that for every request which comes to your flow, it will take 2 seconds to process, or more than that. Let's say it will take 5 seconds to process. So for every request, the client has to wait for 5 seconds. Right? This is too much. So what we might want to do is, we want to design a flow like this, where we'll have a HTTP listener. Now, what I could do is, I can have another flow where I am having the actual logic to do the processing. And I will invoke this flow asynchronously. Right? So my main thread, which is actually executing this flow, will not wait until this processing completes. The next component will be executed and will give the response. So what we want to tell to the clients is, okay, I've got your request. We will be processing it offline asynchronously. And we just want to say to the client, okay, we will take care. In the response, we should be able to give a callback URL to the client so that the client can check whether the message has been processed successfully or not. Okay. So what we are doing, once we receive a request, we are just giving a quick acknowledgement to the client, saying that, okay, we have received your message, we'll process it, and this is a callback URL. To know the status of your request, you can make a request to callback URL, right? So that is what we can do. So now the idea is, this is the main flow. Just give me a minute. I'll show you. Here I have. Yep. See what I have done. Okay. This is the main flow where I will be getting a request to add a product. Assume that we want to add a product. And we know that for adding the product, we want to add the product to database and also send it to a SOAP web service. Assume that this will take 2 seconds and this will take 4 seconds. We don't want the client who is making a request to wait for this much duration. So what my plan is to just have a flow with a HTTP listener. It is actually creating a product object by using the data from the data request. Then I want to insert a data into another table called as product processing status. See, I have a table, product processing status, which has only two columns. Product ID, status. So what I'm doing is I'm inserting the product ID, whatever I'm getting, and status as processing. So we'll insert the status as processing into this table. Then we want to actually have the logic for processing in another flow. So here what I'm doing, I'm publishing whatever message I'm getting, I'm publishing it to a queue called as product queue. And then immediately in the transfer message component, I'm just giving a response, acknowledgement, saying, okay, success. And this is a callback URL, right? Here I'm specifying this is the callback URL and also the time. So the client will get a quick acknowledgement saying that, okay, successfully taken the request, and this is the callback URL. Okay. Now, here I have written a simple flow at that callback URL /product/product ID, which will query the same table based on product ID and give the response. So this is a callback flow. Then the processing of this, actually I have done in this another flow, okay, where actually I'm setting an attribute called as ACK ID. I'm receiving a message on JMS. So whenever I receive a message on JMS, there will be a header called as acknowledgement. So actually, once everything in the flow is success, then only I want to give acknowledgement to the broker. If there is an exception, I don't want to give acknowledgement to the broker. So the message will not be deleted from the queue. So here in this on new message, here I configured it to receive messages from the product queue, but acknowledgement is manual. At the end of the flow, if everything is fine, this component of JMS ACK can be used to manually acknowledge. But while acknowledging, for which message is it acknowledging? I need to get the acknowledgement ID. So actually, in the incoming message, there will be a header. There will be an attribute called as acknowledgement ID. So I don't want to lose it. I stored in a variable so that while acknowledging, I'll be acknowledging a message with this ID. So here I could actually write where's dot, not a, right? Fine. Now, once I received a message, I am setting a variable called as product with a payload. Then I am having a logic to check. I'm calling another flow to check whether product is existing, upsert, and then I'm calling the SOAP web service. And then just to simulate a delay, I have added a logger where I've configured it to wait for 60 seconds. So assume that this is taking too much time. 60 seconds is too much. Maybe I'll give it for 30 seconds right now. So I'm adding a delay of 30 seconds. Assuming that I want to simulate a delay of 30 seconds for processing. Then if everything is fine, I am using update to update the processing status as processed. Okay. Then I am sending the acknowledgement. So let us run and see. This is a one strategy where if you know that the processing takes a lot of time, is to give a quick acknowledgement to the client without processing. Okay, so let me run this. Oh, sorry, I have to actually start my active MQ. Actually, I'm using active MQ as a message broker. I forgot to start it. I will start it. Wait, I'll start active MQ. Okay, I'm just starting active MQ. My message broker. Okay, active MQ is started and it has web UI at 8161. I'll go to localhost 8161. Here, if I see the queues, there are no queues. So let me restart my application. Okay, it got deployed. Now, in my database, let me truncate the table. Product table I truncated. There are no products right now, and you can see in product processing status, there is nothing. Now, let me give a request to add product. I'm giving a request to add a product with ID 5 or ID 1. See, I got a quick response, 200. Okay. Now, let me hit this URL to check what is the status. It is still saying processing, because once I got a request, I published it to queue and this will process it. But I have added a delay of 30 seconds. So until next 30 seconds, just simulating a delay, it will not say, it will not execute this update. After that, update will be executed. I think 30 seconds is over. Now, if I just see, the status is updated as processed. So the idea is, we will give a quick response, quick acknowledgement to the client, and the client can actually go ahead and check what is the status by calling the callback URL. This is another strategy. Okay, synchronous quick acknowledgement strategy. Now, asynchronous processing and broadcast the message to a topic. This is another processing strategy. Let me tell you the scenario for it. Assume that you have multiple, you want to process one single message in different ways. Assume that you are actually getting a request in a flow using HTTP. Once a message comes to your flow, you want the message to be sent to a system 1, a third-party system 1, system 2, and system 3. Right now, you have a request to update 3 systems with whatever message you are getting. So, how to actually process this thing? You want to update 3 systems with this message. What we can do is, we can make these applications listen for messages on a topic, not a queue, topic. These all are subscribed to a topic. These are your applications, maybe system APIs, which will talk to the underlying systems. These system APIs are subscribed to a topic. So whenever your other process API or another application gets a request, you will just publish a message to the topic. So these three applications will be the subscribers to the topic. They will get the message and they will do the processing. So we are doing broadcasting. Topic means it's broadcast, right? We are broadcasting the message and all the subscribers will get the message and they will do the processing of the message. The advantage of this pattern is tomorrow, if you want the message to be sent to another system 4, your logic need not change. This another API will subscribe to the same topic and it will do the processing. This is another advantage of using broadcast pattern. Okay. So the message is processed asynchronously by multiple applications, right? So advantages, you can plug in another application for processing the same message without modifying your actual logic. Okay. So that's the one. Okay, you've come to the end of this. So what you can do now is in my GitHub, in this repository, there's a document 04 event processing models. Here I have nicely documented about the processing strategies like sequential processing strategy, parallel asynchronous processing strategies, and idempotent strategy, quick acknowledgement pattern, etc. So I want you to go through this document step by step. And also in this directory, in this folder of my Git repository, I have the corresponding jars to be imported in Anypoint Studio to do this exercise. So follow this document and complete the exercise before you go to the next topic. See you next topic.